Let us use chain rule to find the partial derivative of z with respect to s and partial derivative of z with respect to t. Z is defined as x minus y to power 5, and at the same time, x depends on s and t, y also depends on s and t. Partial derivative of z with respect to s is partial derivative of z with respect to x times partial derivative of x with respect to s, plus partial derivative of z with respect to y times the partial derivative of y with respect to s, because z has two variables, and these two variables both depends on s and t. So when you're taking the derivative of z with respect to s, you have to take the derivative of x with respect to s, and also take the derivative of y with respect to s as well. So let us begin. This becomes 5 times x minus y to power 4 times 1 times 2st plus 5 times x minus y to power 4 times negative 1 times t squared. So where do they come from? This is your z in x and y. The partial derivative of z with respect to x, since it has an exponent, you're going to take this exponent and write it in front of x minus y to power 5 minus 1, which is 4. And then you're going to apply the chain rule here. The derivative of x with respect to x is equal to 1. Now for x itself, x is s squared t. So when you're taking the partial derivative of x with respect to s, it becomes 2st. Now let us take a look at the second addend. The partial derivative of z with respect to y using chain rule is 5 times x minus y to power 4. And since you have negative y, the derivative with respect to y becomes negative 1. And then the partial derivative of y with respect to s, which is just t squared. You can simplify this by factoring out 5 times x minus y to power 4, and then you get 2st minus t squared. With the same argument, we can find the partial derivative of z with respect to t. The partial derivative of z with respect to t is the partial derivative of z with respect to x times partial derivative of x with respect to t plus partial derivative of z with respect to y times partial derivative of y with respect to t. So since we are taking the partial derivative of z with respect to x, this is exactly the same as what we did before. So you end up with 5 times x minus y to power 4 times 1. But here, what you need to notice is now you're taking the partial derivative of x with respect to t. When you're taking the partial derivative of x with respect to t, you end up with s squared. Then the second addend, partial derivative of z with respect to y, which is exactly the same as what you had before, applying chain rule, times the partial derivative of y with respect to t, which becomes the derivative of st squared with respect to t, or 2st. So this is the second portion that you need to focus on. And then you can simplify this further by factoring out 5 times x minus y to power 4 times s squared minus 2st. Let's take a look at another example for you. Now suppose z is e to the x sine y, x is st squared, y is s squared t. We want to find the partial derivative of z with respect to s, partial derivative of z with respect to t. Partial derivative of z with respect to s is partial derivative of z with respect to x times partial derivative of x with respect to s plus partial derivative of z with respect to y times partial derivative of y with respect to s. So please note that z depends on two variables. Each one of these variables depends on two other variables, s and t. So let us begin. The partial derivative of z with respect to x is e to the x sine y. The partial derivative of x with respect to s is basically t squared. Then we take the partial derivative of z with respect to y, which becomes e to the x cosine y. And the partial derivative of y with respect to s is basically 2st. Okay, so as you can see, you have x, you have y, you have t, x, y, s, and t. Let us do a little bit of substitution. Wherever we see x, we're going to use st squared. Wherever we see y, we're going to use s squared t. So that's how you end up with t squared. E to power x is now becomes e to power st squared sine of s squared t plus 2 times st e to power x, which is now e to power st squared cosine of y, which is s squared t. So our partial derivative of z with respect to s only depends on s and t. There is no x and y anymore. So with the same argument, we're going to find the partial derivative of z with respect to t as well, which is the partial derivative of z with respect to x. You're going to have the exact same quantity. The partial derivative of x with respect to t, now you're taking the derivative of st squared with respect to t, plus the partial derivative of z with respect to y, which is going to be the same as e to the x cosine y, but now we are taking the partial derivative of y with respect to t, which is partial derivative of s squared t with respect to t. This becomes e to the x sine y times 2st, which is the partial derivative of x with respect to t, plus ex cosine y times the partial derivative of y with respect to t, which is s squared. Again, we want to get rid of all of x and y's, so let us do the substitution. When you do the substitution, we get 2st e to power st squared sine of y, which is s squared t. Just substitute that here. And then plus s squared e to power x, which is st squared, times cosine of y, which is cosine of s squared t. Please pay attention here. X is st squared and y is s squared t. Another example for you. Let u be x to power 4 times y plus y squared. Z cubed, x depends on rst, y depends on rst as well, and z depends on rst. So here, u depends on 3 variables, and each one of these variables depends on 3 other parameters. We want to find the values of partial derivative of u with respect to s when r is 2, s is 1, and t is equal to 0. Let us begin, everybody. We're applying chain rule. The partial derivative of u with respect to s is the partial derivative of u with respect to x times partial derivative of x with respect to s plus partial derivative of u with respect to y times partial derivative of y with respect to s plus partial derivative of u with respect to z times partial derivative of z with respect to s. This becomes basically 4x squared, x cubed y r e to t plus x to the 4th plus 2y z cubed times 2rs e to power negative t plus 3y squared z squared r squared sine t. This is my u. So when I take the derivative with respect to x, it basically becomes 4x cubed y. And since the second term doesn't have any x in it, it becomes 0. So that's how you just have 4x cubed y times partial derivative of x with respect to s, which is r e to power t. We continue the process. Partial derivative of u with respect to y is x to the 4th plus 2y z cubed multiplied by the partial derivative of y with respect to s, which is 2rs e to power negative t. And finally, we take the partial derivative of u with respect to z. The very first term doesn't have any z, so it becomes 0, but this guy has z cubed, so you get 3y squared z squared multiplied by partial derivative of z with respect to s, which is 2rs multiplied by sine of t. Okay, what is the rate of change of u with respect to s when r is 2, s is 1, and t is equal to 0? So we have the value for r, t, and s, but what are x and y's? To find the value for x and y, you basically substitute these numbers into the expression given to you. When r is 2, s is 1, and t is equal to 0, you get 2 times 1 e to power 0, which is 1. So x becomes 2. When r is equal to 2, s equals to 1, and t is equal to 0, you get 2 times 1 divided by 1, which is 2. Now for the z, if you plug in 2, you get 4 times 1 and sine of 0, which is basically 0. So z vanishes and it becomes 0. Now substitute everything into the last expression that you have. You have 4 times x cubed, but x is 2, multiplied by y, which is 2, r is 2, t is 0, plus x to power 4, which is 2 to power 4, plus 2 times 2 times 0. So this guy becomes 0. 2 times r, which is 2, times s, which is 1, divided by 1, plus 3. So this is just 0. So this term basically becomes 0. So multiplied by 0, and you end up with 192, which is the rate of change of u with respect to parameter s. This is a positive number. So we have an increase in the rate of change.